Hey guys, today in this video we're going to talk about random forest algorithm. This is a guided step-by-step tutorial for beginners getting started with random forest. In this video we will discuss how random forest algorithm is an extension of decision tree, how it solves the problem of overfitting in decision trees, and what makes random forest algorithm the most popular supervised learning algorithm out there. We will understand everything in detail with the help of examples. What is a random forest algorithm? Random forest is a powerful supervised machine learning algorithm. Even though random forest is most commonly used for classification problem, it works well with both regression and classification tasks. In short, random forest creates several independent decision trees and combines the result to give a more accurate prediction. In cases of classification tasks, random forest builds multiple decision trees on different subsets of samples and takes their majority votes for final prediction, just like it does in this illustration. And in cases of regression tasks, random forest builds multiple decision trees on different subset of samples and takes their average for final prediction. Let's take a quick real-life example of random forest algorithm. Suppose you want to pick a restaurant to go out with your friends. You ask your 5 friends where they want to eat and their responses are as follows. Friend number 1 says KFC for its delicious food. Friend number 2 says McDonald's for its cheap food, and so on. Random forest act in a similar way to this example. Random forest have various decision tree models, just like different friends in the example above. Next, random forest takes subset of features of each decision tree, just like the subset of features taken by each in this example. Random forest combines its predictions by majority voting, just like votes given by friends in the example above. Finally, random forest gives a final output based on majority decision, just like KFC gets the majority votes by friends in the example. Let's dive straight in and learn how to build a random forest classifier. Create a bootstrap dataset that this is our entire dataset. On the left we have our original dataset, and on the right we are going to make our bootstrap dataset. To create a bootstrap dataset same size as our original dataset, we will randomly select samples from original one onto the bootstrap one. So let's start with this sample. Third row from original dataset will go into the first row of bootstrap dataset, and the fourth row of the original dataset will go to the second row of the bootstrap dataset. Hold on, there is a catch. The catch here is that we can pick a sample to appear in a bootstrap dataset more than once. So we can repeat our samples while copying from original dataset to bootstrap dataset. This technique is called as random sampling with replacement. With that said, let's make this sample appear twice in our bootstrap dataset. It will come in the third and the fourth row of our bootstrap dataset. Note that this row didn't end up on our bootstrap dataset. Poor row. Step 2. Create a decision tree with our bootstrap dataset. We will only consider a subset of features at each step. Again, out of the bootstrap dataset, we will only take a subset of features or columns at each step. So instead of taking all features for splitting root node, we will randomly select 2 features out of the 3 for candidates. So these 2 features are our candidates for splitting the root node. Now let's say we compute their Gini impurities and found out the feature eats healthy to be optimal for splitting the root node. We'll place eats healthy at the root node. Then for this node, we'll again select a subset of features. Again decide among 2 randomly selected features, excluding eats healthy. So exercise regularly and age are candidates competing for this node. So we keep building decision tree by considering a random subset of variables at each step. Then we get one decision tree like this. Step 3. Repeat step 1 and 2 for multiple decision trees. We keep on making new bootstrap datasets and selecting subset of features at each step for every single decision tree. We will repeat the process for hundreds of decision trees. Thus, by making a bootstrap data with random samples and considering only subset of features at each step will result in a wide variety of trees, unlike individual decision trees which suffer from overfitting due to lack of variance, and thus making random forest a better alternative to individual decision trees. Note that while implementing random forest in Python, we can define the number of trees we want to build using the n_estimator parameter that stands for number of estimators. So with hundreds of decision trees, we have our random forest model ready to go. Now let's predict for a new person if he is fit or not. So we will run the data down each tree and keep track of all the decisions. So here tree number 1 says no. We will count that in. Tree number 2 says yes. We will count that in as well. Tree number 3 says no. So we will count that under no column. And so on. After running the data through hundreds of trees, we will take majority vote to arrive at final decision. So the class no gets majority of 68 votes. So we will conclude that this person is not fit. Bootstrapping the dataset and aggregating the votes to make a decision is referred to as bagging. Question: how do we evaluate a random forest? Remember that we unfortunately have not included a sample from our original dataset to our bootstrap dataset. Note that this row didn't end up on our bootstrap dataset. This sample is referred to as out-of-bag sample simply because it did not make it to the bootstrap dataset. Since we already know that the correct output is no, we just have to see what each tree predicts as the correct output. Although in practice we have hundreds of trees, here for simplicity's sake let's consider only 5 trees. So we'll run the data down only 5 trees to check the accuracy of each tree. So tree number 1 predicts no. Tree number 2 predicts yes. Tree number 3 predicts no. Tree number 4 predicts no. And tree number 5 predicts no. So obvious majority voting, they have predicted the output as no. We want to see how accurate their predictions are. So we will proceed to check their accuracy scores. In a bigger dataset, we will have a lot of out-of-bag samples to work with that we can also use to run down those samples on this tree. So we calculate accuracy by taking correctly classified outputs and divide them by the total number of output. Here in this case, the accuracy will come out to be 90%.